Hello, Natalie Terry from Natematics here to take you through a lovely, and I mean it, it's an absolutely lovely GCSE circle theorems question. One of a series, so if you haven't looked up the other ones yet, go and have a look right now. So we've got to find angles X, bottom right, Z and Y, and you must give a reason as to why you've calculated any angles you have. Because the thing is, maths is basically using a series of rules to allow you to work things out. So sometimes we don't do them in the order that we need to. Sometimes we need to work out something else before we can get anywhere near the angle that we need. And that's okay. That is absolutely okay. So I'm just going to take a quick drink. I think this might have to be the last one. I think my voice is not going to last that much longer. So let's have a look now. We've got angle X. Now, straight away, and I wrote this at the top here, I said, well, we've got a chord. We've got a couple of chords, haven't we, here? We've got a chord there. We've got a chord there. We've also got a tangent. And we've also got a line going from the center, O, out to the circumference, and it meets the tangent. Okay, so looking at angle X, it meets, this is a segment, isn't it? This is the angle in this particular segment. Is there an alternate segment that comes from this particular chord here? Well, can you form a triangle from that chord that touches circumference? Yes, we can. There's that one there, isn't there? And always remember, they always come off. So any angle that came off this chord and went to the circumference would be 36 degrees on this particular question. Okay, so therefore angle X is 36 degrees based on the angles in alternate segments are the same. You always must state your reasons. Where's your evidence? What are you using to back that evidence up? It's almost like, you know, being in court, isn't it, when I think we're doing a maths problem. Okay, so next thing is angle Y. Now, at this point, if you think, actually, I can work out angle Z, that's fine. You go ahead and do it whatever order you want to. You might actually find that you find angle Y when you're doing it. Doesn't matter, as long as you've got the right evidence and you've worked it out correctly. So therefore, let's have a look at Y then. Now, angle Y, you notice it comes off this chord here. Now, this chord also meets in the other segments. You've got the segment on this left-hand side. You've got the segment on the right-hand side. Now, the angle that this segment makes with the tangent is this one here. So it's a sum of 34 and 36 degrees, so 70 degrees there. So therefore, the angle in the alternate segment at the circumference is 70 degrees as well. And again, based on exactly the same reason. Okay then, so angle Z. What have we got here? Let's have a look where that angle Z is. What is it part of? Now we've got these two lines here, the radii, the radiuses, or duplicate radiuses, which means it's radii, and it goes through the center. The reason I've highlighted this is because you've got an angle here coming from the same chord, haven't you? Now this one's at the circumference. This one is at the center. And what do we know about that angle? We know that actually this is double the angle from the same chord at the circumference. So if that's 70, this one must be 140. Now we've also got a triangle here, haven't we? So this angle here forms part of the triangle that angle Z is in. Now, sometimes this is useful. Sometimes it might be that we need to use another rule. But actually, if you look here, you've got an isosceles triangle because it's the two radii, the radii. That angle is part of the two angles that will be the same, because remember the angles where those two sides are the same, the angle underneath them it forms with the third side, they are the same. So therefore 180 take away 140 gives us 40, divide it by 2 and we will get 20 degrees. So what rules have we used there? We've used alternate segment, we've used angles in a triangle, we've used the angle at circumference is half that at the center. We've also used angles in triangles. We've used that there's an isosceles triangle there as well. So there's quite a few that have been incorporated into this problem. That is likely to happen at your GCSE. Sometimes you might just get a more simpler one, but who knows? The more you practice these, the better you will get at it. All right. Thank you very much for watching. Bye-bye.